Welcome back. This is an Aleks training video on calculating formal charge. If you have an element that has a number of valence electrons and they are shared with other elements that are sharing valence electrons, you are going to have to sometimes mess up the number of valence electrons around an atom because now the compound is really sharing all the electrons somehow. So formal charge is assigned when you're trying to figure out, let's say you have two Lewis dot structures that are very similar, which one is the right one, okay? Then you assign formal charge in such a way that you can think how close to the original electron's valence electrons are the electrons in this compound. How messed up is it? The more messed up that the electrons are, the more they're out of order from where they used to be, the less likely that is to happen. So it's another way of making a proper guess of what a configuration looks like. Okay, so how you do a formal charge is actually really easy. You're going to have a compound here. I'm going to rewrite it. Let's remember at the end that this whole thing equals one positive. So the whole thing is an ion. Say this is a nitrite ion. NO2? No, it's not a nitrite ion. Nitrogen dioxide, positive 1 ion, whatever. I'm going to rewrite it with Lewis dot structures with dots, okay, because we're going to separate the two. So I'm going to have oxygen, and it has 1, 2, 3, 4, 5, 6 electrons there shared with nitrogen. It's a triple bond. And then 2 on the left. So that's 8. 2, 4, 6, 8. All right. The nitrogen is going to have those 3. So that's 6. And it needs another one. 7, 8. Okay. So now nitrogen has 8. And then the oxygen has 2, 4, 6, 8. All 3 have the electron, the octet rule is met. All right, now, when you're assigning formal charge, anything that is a lone pair is assigned to that element. So, for instance, this oxygen's lone pair would be assigned to that oxygen. And then 1/2, let's say these 3 or these 3, whatever, 1/2 of the electrons that are bonding electrons are assigned to each. So if you have a bond of 2 electrons, so a single bond, 1 electron would be assigned to the oxygen, 1 to the nitrogen. In this case, it's a triple bond, so half of those would be 3. 3 would be assigned to the oxygen, 3 to the nitrogen. Okay, so let's find out how many of each that they're going to be. So let's look at how many valence electrons does oxygen have. Let's do this one first. We'll do the left-hand oxygen because it's asking for left-hand oxygen. So how many valence electrons does it normally have? Okay, so oxygen valence electrons is normally, okay, oxygen's in group 6, so it's normally 6. Okay, how many did we assign? All right, we assigned 1, 2, because those are our lone pairs, and then half of the bonding, 3, 4, 5. Okay, so we'll see assigned, we'll just say assigned valence electrons, okay, is 5. Okay, so we've got a positive 1. All right, so we've got the left oxygen is going to have a formal charge of positive 1. Let me go ahead and put positive 1. All right, what about the nitrogen? So the nitrogen is the same. Okay, let me get rid of this now. The nitrogen is the same. We're going to assign, now there's no lone pairs here. You've got a triple bond and a single bond. So I want half of the ones that go to nitrogens in the bonding here. So these 3 will be assigned to the nitrogen, and then 1 in this bond will be assigned to the nitrogen. The other half goes to each partner. Okay, so I've got 3 and 4. So how many is a valence shell of a normal nitrogen? Okay, well it's 1, 2, 3, 4, 5. It's in group 5, so it normally has 5. So normal nitrogen valence electrons, it's 5. Okay, assigned nitrogen valence electrons. Okay, let's do it again. We have 1, 2, 3, 4. Okay, so it's 4. Subtract that. You're going to have positive 1 again. So the nitrogen has a positive 1. Okay, so far so good. This is not hard. All right, let's get rid of this now. All right, let's do it again. Now we want the oxygen. So the oxygen has these two, because they're lone pairs, these two lone pairs, these two lone pairs, plus one of the bonding pairs. So that's 2, 4, 6, 7. Okay, so a normal oxygen valence electron is in group 6. So there's 6. Assigned oxygen valence electron is 7. 6 minus 7 is -1. This is -1. Okay. Now here's the test. Remember, I asked you to remind yourself or remember that this added up to a positive 1. The whole ion added up to a positive 1. The formal charges that you assign to the different elements in it will also equal that charge. So I've got positive 1 and positive 1 is positive 2. Minus 1 is positive 1. Okay, so this is okay. And I think that's your answer. Okay, so not hard, different than you've done, but I don't think it's hard.